Okay, guys, today we are talking about momentum and the conservation of momentum. So go ahead and pause it for a second, get your Cornell notes set up, get these learning targets in, and then I want you to think about what has more momentum, a train going 40 miles per hour or a cyclist, someone on a bike going 40 miles per hour. So go ahead and pause, get that done. Okay, so obviously, we all know that the train is going to have the most momentum, but what exactly does that mean? Well, our equation for momentum is going to be P for momentum equals mass times velocity, but it's just the measurement of mass in motion. Um, so whenever you're asked that question, the units for it are going to be kilograms times meters per second. Impulse is a little bit different. An impulse is going to get a little bit tricky, but it's mainly just the change in momentum. Impulse J equals force times change in time. Force times change in time also just equals our change in momentum. So we can say that impulse just equals change in momentum. This whole relationship is called the impulse momentum theorem. And you might think, okay, what does that even mean? Well, it helps us because we're able to connect force to change in momentum. We're able to solve things for the amount of force applied to it, and we're able to figure out what the momentum is because we're able to calculate what the change in momentum actually is. And we'll walk through some of the problems here in this PowerPoint. But objects will have the same amount of momentum whether they are in space or on Earth. That's important to note. It doesn't have to do with weight, it has to do with mass. So if it has 100 kilogram meters per second worth of momentum on Earth, it's going to have that same amount in space. So let's talk about a first set of problems that you might see on the homework. We have a 1,000 kilogram spacecraft that is orbiting the Earth at 767 meters per second. How much momentum does the spacecraft have? Well, just using our P equals m times v, we're able to plug in our mass and our velocity, and we're going to get a momentum of 767,000 kilogram meters per second. Pretty basic question. We can manipulate this around as much as we want. You can solve for mass, you can solve for velocity. You just have to change your original equation a little bit. Let's look at another problem. If I have an offensive and defensive lineman that are colliding during a football game, and the offensive lineman has a mass of 105 kilograms and is going 24 meters per second upon collision, and the defensive lineman has a mass of 120 kilograms and is going 20 meters per second, who's going to win? So go ahead and take a second to think about this. The offensive lineman has less mass, but it has more velocity. So who do we think is going to win? Well, let's calculate our offensive lineman first. Using our equation, momentum equals mass times velocity. We do 105 times 24, and we end up with 2,520 kilograms meters per second. Let's take a look at our defensive lineman. Same equation, P equals m times v. 120 kilograms times 20 meters per second is going to give us 2,400 kilogram meters per second. So we're going to see that even though the offensive lineman doesn't have as much mass, because he's going 24 meters per second, he ends up winning this collision. He's going to knock over the defensive lineman. Conservation of momentum. So what does that mean? Conservation. Conservation is going to mean that we're going to have the same value before an event versus after an event. We want to conserve it. So the conservation of momentum means that all of the momentum that is in a closed system is going to be the same before a collision as it is after a collision. We express this as P1, or momentum of our first object initially, plus the momentum of our second object initially, and all of our initial momentums added together are going to equal our momentum of the first object and the final momentum of our first object, plus the final momentum of our second object and all other objects. All that, they're going to be equal. A closed system means that there's no external forces interacting with our system. I'm running out of time, so I'm going to come back to this in the next video.